Welcome back. Today we are going through lesson 5-6, which is all about solving systems of inequalities by graphing. In previous lessons, we've talked about how to graph an inequality. Now we're going to do a system of inequalities, which is two or more inequalities with the same variables. We're going to graph them together, and to find the solutions, we're looking for any ordered pair that satisfies all the inequalities in the system. So we're looking for XY pairs where they fit into the solutions for all of them. So from prior information we've done, we know that we can graph these two linear functions. I'm going to graph this first one, y equals 2x. So I know that the y-intercept of that is at 0, 0, and its slope is 2. So it's going up 2 over 1 across the page, or down 2 over 1. And when I do that, I also notice that it has a greater than symbol. That means that it is a dashed line, and greater than would be shaded above it. The second inequality is y is less than or equal to negative 1/3 x minus 2. So it starts at minus 2, and it's going down 1 over 3, or up 1 left 3. So it looks something like this. This one has a less than or equal to, so it is a solid line across there. And because it's less than or equal to, I know it is shaded below it. I am looking for where both inequalities are true. So that's where that shading overlaps. So my solution to this is where the teal and the red overlap. So I'm going to erase the things that are outside that. And I can see that my shaded region is this area down here, kind of makes a triangle quadrilateral shape, where they overlap. The next question that they ask us is, based on that graph, which point or points satisfy both equations? So which ones are where both are happening? So if I look at those points, 2, negative 5, that would be over here. That is not in my shaded region. Negative 5, negative 3, that would be in my shaded area. So I know that one is. And then let's just double check. Negative 1, positive 2, that would be up outside that. So negative 5, negative 3 of those points is a solution. Remember, any point in those double shaded areas are solutions. So for our purposes, we're just going to check negative 5, negative 3. So I'm going to plug it into both inequalities. Remember, our first inequality was y is greater than 2x. So if I check my point here, negative 3 is the y value, x is the negative 5. I get that negative 3 is greater than negative 10. That is true, so it checks there. Let's check it in the other inequality. So our other inequality was y is less than or equal to negative 1/3 x minus 2. So we're going to check that xy pair again. We're going to say negative 3 less than or equal to negative 1/3 minus 2. And I get, when I simplify that, that negative 3 is less than or equal to negative 1/3. When I do that, I can see that negative 3 is less than or equal to negative 1/3, so it works in both of them. Let's try example B here, make sure we're all set. So for this one, I again have two inequalities that I'm going to graph. The first inequality up at the top is y is greater than or equal to x minus 6. So starting at x minus 6, going up 1 over 1, and that one's greater than or equal to, so it is going to be a solid line across those. Greater than or equal to is shaded above that line. And then my second inequality is y is less than negative 3x. That starts at 0, 0, goes down 3 over 1, or up 3 over 1. It's less than, so I'm going to make a dashed line and shade below it. So again, when we're doing systems of inequalities, we're looking at the area where both shaded regions overlap. So I'm not going to worry about where just the pink is or where just the purple is. I am concerned about this area where both shades are happening. So it's that area to the left there. All right, then we're going to check again to see what solution makes sense. So looking at our graph here, let's look at those solutions. 1, -7, that's down here, which is in the purple shaded, but it's not in the pink shaded, so that doesn't work. 3, 2 is up here. It's not in any of the shading, so it is not a solution. -4, -2, that's right there in that shaded area, so that one is a solution. Let's double check it with our algebra here. So I am going to say y is greater than or equal to x minus 6. So my y value is -2, my x value is -4, and I get that -2 is greater than or equal to -10. That is true. Let's try the second one, the second inequality, to make sure that it works in that one. My second inequality was y is less than -3x. So let's see, is -2 less than -3 times -4? That's -2 is less than 12, and that is true as well. So we can graph them, and we can find solutions in them. Since we have systems of inequalities that are graphed on the same coordinate plane, their solutions are any of the ordered pairs in the region where the shading overlaps. So we're looking for that overlap. Okay, we're going to move on to some practice now. So these first 4 practice problems, we are going to graph these systems. Let's talk through a little bit about what we would do here. So we would graph each line. Remember, then we would decide if it's a solid or dashed boundary line. And then I would decide where I was going to shade. And then I would emphasize where both shadings overlap. So for this one, I noticed that my 2 lines are parallel because they have the same slope. One is shaded above it, the other one's shaded below it. So they're overlapping. It's going to be in between those 2 lines. So my graph would look something like this. Both solid because they're equal to, and again, they're parallel lines. One's less than, one's greater than, so the shading is in between them. On D, we have a little different situation going on here. The top one is a linear function, but the second one is a quadratic function, so we need to graph those differently. For that linear, you would do it the way we've talked about. It's in slope-intercept form. For the quadratic, you may need to create a table for yourself. That one's in vertex form, so I know that it goes through the point -3, 5. You could find some points around it to help you plot it. And we know it's reflected because of that negative out in front, so it's going down. So we would graph that quadratic. The linear is going to be dashed because of that just greater than. The quadratic is going to be solid. The linear is going to be shaded above the line, and the quadratic is going to be shaded inside the parabola because of that less than symbol. So when we graph those together, we get a graph that looks like this. So above the line, inside the parabola, that overlapped shading is in between the line and the U shape, basically. Okay, let's move on to E and F here. So in E, we now see that we have 3 functions, okay? These are 3 linear functions, so I can see that my first one, I'm going to need to rewrite that in slope-intercept form. So remember, when we divide by -5, that's going to flip the inequality symbol around because we're dividing by a negative. My slope would be 3/5, and my y-intercept would be 3. So I have a positive slope line going through 3. That one, let me show you the final result, and then we can talk about where these things are appearing on the graph. That line is this one. So that's that solid line going through 3, slope of 3/5, and it's less than or equal to, so it's solid and shaded below. The second one is already in slope-intercept form, so we know it starts at -2, and it's got a very steep slope, -6. So that is this line. It is less than, so it's a dashed line, and shaded below it. So you can see that shading on the left side. And then the last equation, or inequality, is y is greater than or equal to 0. that line, since it's greater than or equal to, is a solid line right across the x-axis. Y's of 0 lie on the x-axis. So those are my 3 lines that are going on. And based on the inequality symbols, we need to be above that green line, less than the blue line, below it, and below that red line. So it's that little triangle in between. F example also has 3, but this time it has 4, so it's got even more than 2. So again, we would want to write those either in slope-intercept form or use your x and y intercepts to find those. It's up to you. If I rewrite this first one in slope-intercept form, it would be y is less than 4x plus 3. So again, I'm going to show you the graph and then we can kind of identify things. So y is less than 4x plus 3. That's this dashed line. There it is. And it's less than it, just less than, so it's dashed. The second one, this one, pretty easy to find your x and y intercepts here. Your x-intercept would be 3. Your y-intercept would be 9. So I can see those points on my graph here. It's less than or equal to, so it's going to be a solid line, and we are shading below it. The last 2 inequalities are x is greater than or equal to 0, and y is greater than 0. So x is greater than 0. That's going to be a solid line going right down that y-axis. And x is greater than, or sorry, y is greater than 0 is going to be that dashed line right across the x-axis. So it's greater than the x-axis and greater than the y-axis. So that's why it's only in that first quadrant. And then it's shaded below the 2 linear functions. So it's in between those 2. Okay, these last 2 examples here are kind of working backwards. So it's asking us to find the inequalities based on the graph. So I see 2 functions here, 2 linear functions. The first one I'm going to look at is this one. So I can see that it goes through a y-intercept of 1, and it looks like the next solid point is that one, which means it's going up 6 over 1. So that inequality, the function, is 6x plus 1. Then I just have to decide the inequality sign. It's a solid line, so I know it's got equal to, and it is shaded below it, so it's going to be less than or equal to. The other function is this dashed line, so I know it's not going to have equal to. It looks like the y-intercept is at -4, so I know I've got a -4. And it looks like the slope is going up 1 over 2. So that is my slope. And again, this one's shaded above, so it would be greater than, but not equal to because it's dashed. That would be my system for that one. Okay, last example before we get into some practice problems. This one I can see a quadratic and I can see a linear function. So let's start with the linear function, this line going across here. So it looks like that y-intercept is at 2. So we have a y-intercept of 2, and it looks like my slope is going down 1 over 1. So that's a -1 slope. It is a solid line, so it's equal to, and it's shaded below it, so less than or equal to. And then for the quadratic, I see that the vertex is at 0, -3, and it doesn't have a stretch or a shrink at all. So my vertex form is going to be x squared minus 3. Or you could say x minus 0 squared minus 3, either way. And this one's dashed, so it does not have an equal to part, and it's shaded above it. So it's going to be just greater than that quadratic. Okay, we're going to get into some practice here. so we are going to go through these first 4 together. Okay, so these are the type of questions that are asking us if the ordered pair is a solution or not. So we have a graph, we're given that, and we're trying to decide if 1, 6 is a solution. So let's check. If I go over to 1 and up to 6, I can see that that is not inside my shaded region or on a solid line. So that is a no. For number 2, the ordered pair is -1, +4. I can see that that one is inside both shaded regions. So that is a yes. The second 2, we are not given the graph. We are given the inequalities. So we're going to check algebraically if this XY pair works. So for the first one, I can say that 4 is less than or equal to 1/2 of 10. And I can see that 4 is indeed less than or equal to 5. So that one works. Let's check the other one. Our second inequality that I'm going to check is -4 times the x value plus the y value, and we're going to see if that is indeed less than or equal to -5. Remember that it has to work in both. So just because it worked in the first one doesn't mean it's going to work in the second. We need to check both. So this is going to be -40 plus 4 is less than or equal to -5. And that means that -36 is less than or equal to -5. That is true. So this one is a yes for both of them. It is a solution to these inequalities, this system. Okay, for example 4, practice problem number 4, we've got our XY pair of 3, 2. Let's check it in each inequality. So for the first one, we've got an x value of 3 and a y value of 2. And we want to see if that's greater than or equal to 3. So when I get there, I get -6 plus 10 is greater than or equal to 3. That's 4 is greater than or equal to 3. That is true. Let's check our second one now. So is the y coordinate less than 4? It is. So that one is true also. Now remember, it has to work in all of the inequalities in the system, so we are going to check the third one. Even though we've already gotten 2 trues, we got to check all 3 of them. So -4 times x plus 2 times y is less than 7. That would be -12 plus 4 is less than 7. And -8 is less than 7. That is also true. So this one is indeed a solution to all 3 in the system. All right, for these final 4, I encourage you to try these on your own and see how you do with graphing those. Remember to graph them, decide whether it's a solid or dashed line, decide where your shading goes, and then look for the overlap in the shading. All right, we'll see you next time.